Netfabb Local Simulation 2026 includes a new feature for Toolpath-based layer times. This feature uses the TDWL card, and its argument is the name of a JSON file which contains layer timing data. This new feature can be a more accurate alternative to the solver's default calculation, which calculates layer times based on the processing parameters. If your toolpath uses multiple contour passes, the toolpath-based layer time can be a more accurate timing calculation. Opening the layer time JSON files shows that it contains time data and layer z-coordinate data. The time coordinate is representing the duration of each layer in seconds, so 14.5 seconds for the first layer, and then again roughly 14.5 seconds for the second layer. Later down, these numbers start to increase for bulkier sections of the build. After the time array, there is a z-coordinate array having z heights in millimeters. My layer thickness is 50 microns, so all of these z-coordinates are multiples of 50 microns in millimeters. For comparison, I will run a simulation using the new toolpath-based dwell time and without the toolpath-based dwell time. Without dwell time, I'm simply commenting out the new card. I will run the simulation at the command line using pan2. I'll run them back to back, first the toolpath-based layer time, and then the default. After the simulation completes, we can inspect the log files to see the impact of the toolpath-based layer time. With the default timing calculation, we can see that the simulation has a total build time of just over 8,500 seconds. We can inspect the log file of the toolpath-based layer time simulation to see the difference. We can search the log file for build time to see the total build time. This is the sum of all of the times in the layer times JSON file. Here it is just under 9,400 seconds. If we go to the end of the log file, we can see that the time of the last increment matches this total build time, just under 9,400 seconds. Again, comparing that to the default log file, it's about a 10% difference. The default timing is slightly shorter than the toolpath-based layer times. The results of both simulations can be imported into Netfabb Local Simulation to compare the temperature differences. First, we'll look at the default results. I'll step ahead several increments into the simulation to look at this time increment. Next, I'll import the results of the toolpath-based layer time simulation. Again, I will step forward to the same increment to compare both simulations at the same time. I can now switch tabs to compare the results of both simulations. So, with toolpath-based layer times, we can see that this increment happens just under 6,700 seconds. With the default timing calculation, the same layer happens earlier at 6,053 seconds. In addition to the time, you can also see differences in the temperature results. With toolpath-based layer times, the maximum temperature is 474 degrees C. With the default timing, the temperature is 513 degrees C. This makes sense that the default temperature is hotter because there's less build time at each layer. So with less time for cooling, the temperatures are higher. Toolpath-based layer times are seamlessly integrated with the advanced Toolpath utility in Autodesk Fusion. The advanced Toolpath utility can automatically generate the layer time JSON files. However, because this format is a text-based, human-readable JSON format, if you know details about the timing from your machine manufacturer, you may be able to create this file yourself.